Hi everyone, welcome back to Chapter 3 of Data Teacher's YouTube series on Introduction to Python. Today we'll be going over Lesson 3, which is on conditionals and loops. So first, let's go over some types of conditionals. And in Python, we use the same logical conditions that we use in mathematics, but with a slight difference in syntax. So here are the conditionals for Python. If we want to see if two values a and b equal each other, we use equal sign, equal sign. If we want to check if two values do not equal each other, we use exclamation mark, equal sign. And if we want to see if a is less than b, we use the less than sign. If we want to see if a is less than or equal to b, we use less than and then equals. If we want to see if a is greater than b, we use the greater than sign. And lastly, if we want to see if a is greater than or equal to b, we use the greater than sign and then the equal sign. And the return value of conditionals in Python is always going to be a Boolean, so true or false. So now let's talk about if statements. If statements tell a program to perform certain actions if a condition is true, and the actions you want the code to perform must be indented. So the syntax of this is going to be if, and then your condition, and then the colon sign, and then on the next line, you're going to indent the code that you want to run. So as an example, I have written out if 10 is greater than 5, and then the colon sign, and then on the next line, I indented this print statement, which prints the string 10 is greater than 5. And when I run this code chunk, it's going to output 10 is greater than 5. And that's because the conditional 10 is greater than 5, and that's because the conditional 10 is greater than 5 is going to evaluate to true, and we're only going to run the code in the code chunk below the if statement if that conditional is true. So now moving on to if-else statements. An else statement in Python tells a program to perform certain actions if the corresponding if statement evaluates to false. So the syntax for this is if condition, colon, and then on the next line, the indented code is the code you want to run if the condition is true. And then after all of that code, we're going to have else, and then colon sign, and this else statement is going to be in line with the if statement above, and below the else statement, we're going to have the indented code that you want to run if condition is false. So as an example, let's say I created a variable named raining and I set it equal to the Boolean false. And if raining is equal to true, it's going to print the string it's raining outside. Otherwise, it's going to print it's not raining outside. And we know that to be the case because of the else statement. So when I run this code, it'll print it's not raining outside because we know that false does not equal true. So the condition is going to be false, which means we run the else statement. And now let's talk about if, elif, and else statements. So an elif statement, also known as an else-if statement, tells a program to perform certain actions if the corresponding if statement evaluates to false and the new condition is true. And if the if statement's condition evaluates to true, then the remaining elif and else statements will never run. So let's go over the syntax for this. First, we're going to have if condition 1, and then below that if statement, all the indented code is going to be the code you want to run if condition 1 is true. Then we'll have elif condition 2, and the code below this elif statement is going to be the code to run if condition 1 is false and condition 2 is true. And below that, we'll have the else statement, and all the code in that indented chunk of code will only run if condition 1 and condition 2 both evaluate to false. So as an example, let's look at this if, elif, else statement, and then we'll talk about what it'll output. So first I have if temperature is greater than or equal to 90, it'll print it's really hot. Else if temperature is greater than or equal to 70, it'll print it's pretty warm. Else if temperature is greater than or equal to 50, it'll print it's getting chilly. And lastly, if none of the above statements are true, it'll just print it's really cold. So in this first example, I set the variable temperature equal to the integer 95. And first, we're going to check if temperature is greater than or equal to 90 and see what that evaluates to. And we know 95 is greater than or equal to 90, so that first conditional is going to evaluate to true, and it's going to print it's really hot. And all the statements below, the elif, and the else, are never going to be run because the if statement already evaluated to true. So the only thing that is outputted is it's really hot. In this following example, we set temperature equal to 58. And now let's see what this will output. So if temperature is greater than or equal to 90, we know 58 is not greater than or equal to 90, so it'll move to the next elif statement. Then we check if 58 is greater than or equal to 70. That's not the case, so we move to the next elif statement. Then we check if 58 is greater than or equal to 50, which is true, so we print it's getting chilly. And now we're not going to run the else statement because the else statement already printed, so the only output is going to be it's getting chilly. In this last example, we set temperature equal to 34, and let's see what this will output. So 34 is not greater than or equal to 90, so we move to the next elif statement. 34 is not greater than or equal to 70, so we move to the next elif statement. 34 is not greater than or equal to 50, so we move to the else statement, which only happens if the above three statements all evaluate to false. And since that's the case, we're going to print the else statement output, which is it's really cold. Now let's briefly talk about nested conditionals and logical operators. So if you have a nested conditional, which is essentially just an if statement within an if statement, you can rewrite it using logical operators. So here are the logical operators in Python. So let's say we typed condition 1 and condition 2. So this will evaluate to true if condition 1 and condition 2 are both true. Next, let's say we had condition 1 or condition 2. This will evaluate to true if either condition 1 or condition 2 evaluates to true. And lastly, if we have not condition 1, this just returns the opposite of condition 1. So if condition 1 was true, then not condition 1 will be false. So as an example of this, let's say I created the variable age and I set it equal to the value 15. And I have an if statement within an if statement, which is a nested conditional. So if age is greater than 12, it'll move on to the next code chunk, which is if age is less than 20, and then it'll move on to the next code chunk, which is print I am a teenager. So when we run this code, it'll print I am a teenager because 15 is greater than 12. So we move on to the code within this if statement, which includes the if statement age is less than 20. We know 15 is less than 20, so it'll move to the next statement within this if statement chunk, which is to print I am a teenager. However, we can rewrite this using logical operators to be more smooth and streamlined. So in this example, it's the same as the previous example, except written differently. So age is equal to 15, and we can write this using the logical operator and. So we'll write if age is greater than 12 and age is less than 20, and it'll print I am a teenager. And when we run this, it'll print I am a teenager because both conditions must evaluate to true, and since 15 is greater than 12 and 15 is less than 20, this logical operator statement will evaluate to true. So just as a recap, both of these code chunks will produce the same output, but using logical operators is simpler and more common. So let's do some practice. Predict the output of the following code statements, and feel free to pause the video and come back to review the answers. So in the first question, the output is going to be this is a false statement, and this is because we have the if statement if the string 5 is equal to the integer 5. And this is going to evaluate to false because those are not going to be the same thing because they're different data types. So we skip past the code chunk of the if statement and we move to the else statement. Since the if statement evaluated to false, we're going to execute whatever is in the else statement code chunk, which is to print this is a false statement. In question 2, the answer is going to be A and then D. And we know this to be the case because we created a variable x is equal to 30 and we created a variable y is equal to 20. And first, we're going to check if x plus y is greater than or equal to 40. X plus y is going to be 50, which is greater than or equal to 40, so we're going to print A. Because this if statement evaluated to true, we skip the elif and we skip the else statement. However, we see at the very end of this code chunk, there is a print statement to print D. Since this line is not indented in the else statement, it's not a part of the else statement chunk, so we're just going to run this line no matter what, which is why the output is going to be A and then D. In the third example, the answer is going to be true, and this is because we evaluate using the same rules as PEMDAS. So first, we're going to do the things inside the parentheses, and then we move beyond that. So in the first parentheses, we have true and false. And for the AND logical operator, both the conditions must be true. And since this is not the case, that means the first conditional is going to be false. And in the second set of parentheses, we have true or false. And for the OR logical operator, only one of the conditions must be true. Since that's already the case, this is going to evaluate to true. So now we have false or true. And again, the OR logical operator just needs one of the conditionals to be true. And since the second conditional is true, this is going to output true. Let's do one more example before we move on to loops. So write a program that will check if a person is eligible to vote. And for this example, we're going to use the following rules. The person must be at least 18 years old, and they must be a citizen. So this is the solution that we came up with. Yours may look a little bit different, but whatever works best for you. So for this example, we created a variable age and we created a variable is_citizen to test different cases. And for the if statement, we wrote if age is greater than or equal to 18 and is_citizen. And if that's the case, we can print you are eligible to vote. And notice for the second conditional, we didn't type is_citizen is equal to true because that's going to be redundant since is_citizen is already a Boolean value and we do not need to check if a Boolean value is equal to a Boolean value. So when we run this code, it's going to print you are eligible to vote because this person's age is 20 and is_citizen is true. So when we check if 20 is greater than or equal to 18, that evaluates to true. And is_citizen is true. So true and true is going to give us true. So we'll print the string you are eligible to vote. So now let's talk about for loops and while loops. Loops allow us to repeat a chunk of code multiple times. And a for loop specifically is when you want to repeat the code a fixed number of times, while a while loop is something you will run until the condition is false. And just as a review, some iterables in Python that we have discussed already include lists, which we can use in for loops as they'll cycle through each element in a list, and then strings, which will also be used in for loops, which will cycle through each character in a string. So let's go over the syntax. For a for loop, we'll type for, and then a variable name for the item, and then the keyword in, and then the iterable and a colon sign. And then the indented code below the for loop statement is going to be the code to run for every item in the iterable. For a while loop, we're going to have while, and then a condition, and then a colon sign, and then the indented code below the while statement is going to be the code to run while condition is true. And something to discuss before we look at a few examples is the range function, which helps us create sequence of numbers. And for a range function, you can specify a start value, but if one is not specified, the default start value is going to be 0. And then the end value is non-inclusive. And you can also specify a step value, which is how much to increase or decrease the numbers each time. So for example, range 10 is a sequence of numbers from 0 to 9, so 0, 1, 2, 3, all the way to 9. And that's because we include the start value 0 and the end value is 10, but we do not include 10, so it just goes to 9. So a few examples of using the range function. So in this first example, we're going to print using a for loop to count from 1 to 5. So now let's test this using a for loop and the range function. So we've written out for I in range 1, 6, print I. So what this means is that for every value in the sequence of range 1, 6, we're going to print that element. So range 1, 6 is going to start at the value 1, and it's going to increment 1 at a time all the way into 6 non-inclusive. So this will just give us 1, 2, 3, 4, 5. And when we run this for loop, it's going to print 1, 2, 3, 4, 5. In this next example, we're going to print using a while loop to count down from 5 to 1. So first we set variable count equal to 5, then we create our while loop. So while count is greater than or equal to 1, we're going to print count, and then we're going to do count minus equal 1. And that's the same thing as writing count is equal to count minus 1. And then after that while loop finishes running, we're going to print lift off. So this output will give us using a while loop to count from 5 to 1, and this will do 5, 4, 3, 2, 1, lift off. So now let's do some practice. So predict the output of the following code chunks, and feel free to pause the video to review the answers yourselves and then come back to discuss the solutions. And as a hint, continue will automatically move to the next iteration of the loop. For question 1, the answer is going to be 1, 3, 5, 7, 9. And we know this to be the case because we have for I in range 1, 10, 2, print I. So this range function means that we're going to start at start value 1, and we're going to go all the way until the end value 10, but we're not going to include 10, and we're going to increment each value by 2. So this will do 1, 3, 5, 7, 9. And this iteration of for I in range 1, 10, 2 will print each element in this sequence. So it'll print 1, 3, 5, 7, 9. For question 2, the answer is going to be GTB. And we know this to be the case because we created a list animals that contains the strings dog, cat, and rabbit. And then we have a for loop of for animal in animals. We're going to print the character in the animal string at index 2. So in the first iteration of this loop, animal is going to store the value dog, and we're going to print the element at index 2 of dog, which is the third element, which is the character G. Then in the next iteration of this loop, animal will be the value cat, and when we print the third element in cat, it'll be T. And lastly, for the last iteration of the loop, animal will equal rabbit, and it'll print the third character of rabbit, which is B, and so that's why we have GTB. And lastly, for question 3, the answer is going to be 1, 3, 5. And so we know this to be the case because we created a variable x equal to 0, and we have a while loop. So while x is less than 6, we're going to run the following code. First, we're going to do x plus equals 1. And then if x modulo 2 is equal to 0, we're going to continue. So we're going to go to the next iteration of the while loop. After that, we're going to print x. So in the first iteration, x is equal to 0. We check, is 0 less than 6? That is the case, yes. So we do x plus equals 1. This is the same thing as x is equal to x plus 1, so x now represents 1. 1 modulo 2 does not equal 0, so we're not going to continue on to the next iteration, and we're going to keep on going with the statement in the while loop, which is to print x, which is why we get our first output of 1. Then we go back into the top of the while loop, and we check the condition again. So now x is 1, so is 1 less than 6? Yes. And we're going to do x plus equals 1, so x is now 2. Is 2 modulo 2 equal to 0? Yes. So we're going to continue into the next iteration of the loop. So now x is equal to 2. Is 2 less than 6? Yes. We enter the while loop. 2 plus equals 1. 2 is now 3. Is 3 modulo 2 equal to 0? No. We're going to exit the if statement, and we're going to print the value of x, which is 3. Then we go back to the top of the while loop with x now equaling 3. Is 3 less than 6? Yes. We enter the while loop. X plus equals 1. X is now the value 4. Is 4 modulo 2 equal to 0? Yes. So we're going to continue into the next iteration of the loop with x now equaling 4. Is 4 less than 6? Yes. We do x plus equals 1. X is now 5. Is 5 modulo 2 equal to 0? No. So we exit the if statement. We print 5. Now we go back to the top of the while loop. Is 5 less than 6? Yes. We add 1 to x. X is now 6. Is 6 modulo 2 equal to 0? Yes. So we continue to the top of the while loop with x now equaling 6. Is 6 less than 6? No. So now we can finally finish our while loop, and we are now done with this code with the output 1, 3, 5. Thank you so much for watching this video on conditionals and loops, and we'll see you in our next and final lesson of this chapter on functions.